Heat around the equator. Hot summers in the Mediterranean. Spring, summer, fall, and winter in New York. Snowstorms in Greenland. And icy temperatures at the South Pole. The global climate can be divided into multiple zones. Here, a range of factors come into play. Among the most important is the sun. Depending on the position of the Earth relative to the sun, it heats the land and water more in some places and less in others. In this process, warm air rises while cold air sinks. This results in wind, water vapor, and rain clouds. All this contributes to climate distribution. There is a line around the center of our globe called the equator. The regions surrounding this line are the tropics. Since the sun's rays hit the Earth here almost straight on all year round, days are basically the same length and also just as warm whatever the season. Depending on the altitude, temperatures range between 50 and 0 degrees Celsius. The tropics are home to rainforests with lots of precipitation, where plants grow in abundance, as well as extremely dry regions, such as the savannas in Africa. Adjacent to the tropics are the subtropics. The summers are very hot, but the average temperature of the coldest month remains below 20 degrees Celsius. The subtropics include a number of deserts, as well as the Mediterranean region. Here the summer months are relatively dry, while in winter plenty of rain makes the landscapes flourish. And then there are also regions where every month brings scattered showers. Different plants flourish here at different times of the year. The temperate zone, which includes New York, is defined by the familiar seasons. Winters can be icy cold, with a maximum of 4 daylight hours in some areas. On the other hand, summers are pleasantly warm, with up to 16 hours of sunshine. This zone is primarily home to deciduous, coniferous, and mixed forests. With the subpolar zone, we move farther still from the equator. Sunlight hits the Earth at a very shallow angle here, which is why the days in summer can be extremely long. Temperatures are typically just above freezing, and there is lots of precipitation. By contrast, winter days are very short, and due to the polar easterly winds, really cold with low precipitation. In the subpolar regions, coniferous forests can still be found in some areas. The closer you get to the polar caps, the bleaker and colder it becomes. Now we are left with the polar zones, also known as cold deserts. At the North Pole is the Arctic, with lots of lowland. At the South Pole is Antarctica, with lots of mountains. Almost no plants grow in the polar zones because the conditions are far too poor. In the summer, it stays light throughout the day and night, while in the winter it remains dark for almost half a year. Temperatures regularly exceed 0 degrees Celsius. These climate zones can be divided further, such as into biomes or vegetation zones. The boundaries between climate zones are rather blurred. As a result of global warming, the zones are moving, making all regions warmer and drier. So it's possible that New York may eventually look like this in the future.
The climate refers to the prevailing average weather patterns of a region over a long period of time. For example, over a 30 to 50 year period. Weather is the daily atmospheric conditions consisting of precipitation, temperature, humidity, wind, and sunshine. Around the world there are different climate zones. In some regions there are hot and dry deserts. In other places there are warm and wet tropical rainforests, while other places are covered in ice. Why is this so? Now let's examine the main factors that influence the climate of a region. Latitude refers to location in the globe in relation to the equator. Generally, the closer to the equator a place is located, the warmer the temperature is, while the further away from the equator, the colder the temperature is likely to be. This is because on the equator, sunlight or insolation strikes the Earth at roughly a 90-degree angle. This results in intense solar energy as there is consistent length of day. That is 12 hours a day, 365 days a year. Regions close to the equator have warm temperatures all year round. Tropical rainforests thrive in equatorial regions since plants love this consistent light that powers photosynthesis. Because the Earth is spherical, this solar energy diminishes as you move further north or south of the equator. Regions closer to the poles have 4 seasons and very cold winters. Altitude refers to the height of land above sea level. Saturated air cools at the rate of 0.6 degrees Celsius per 100 vertical meters, so at 1000 meters it will be 6 degrees cooler than at the same latitude at sea level. Therefore, high altitude regions such as the Himalayas will be much cooler than other locations at sea level on a similar latitude such as Shanghai. Mountains can also influence climate in other ways. For example, they can produce what is known as orographic rainfall. This occurs when moist air is forced to rise over mountains. The windward side of the mountain will have a wet climate, while the sheltered leeward side usually has a drier climate. We call this the rain shadow area. For example, in New Zealand's South Island, the prevailing westerly winds force moist air from the Tasman Sea to rise over the Southern Alps. Most of the rainfall is dumped on the west coast, which has the wettest climate in New Zealand. The climate east of the ranges in Canterbury is dry. Relief features can also cause wind funneling. Cape Horn, for example, is infamous for its winds due to the wind funnel between Cape Horn in Chile and the Antarctic Peninsula. Another windy place affected by relief is Wellington, the capital city of New Zealand. This is due to its location on the Cook Strait, the waterway between the North and South Islands.
This tunnel is having the effect of being an artificial wind funnel. It's blowing like crazy here. It's the same effect that you get in the Cook Strait, where the North and South Island are your two land masses and the wind is pushed through the Cook Strait.
The size of landform and proximity to oceans is another important climatic influence. Small land masses such as islands have maritime climates. Islands have small temperature variations due to the moderation of the climate by the sea. Auckland, in New Zealand for example, has a relatively low temperature variation, being located on an isthmus surrounded by water with a harbour on either side. Auckland's average daily maximum temperature is 23.7 degrees Celsius in February and 14.5 degrees Celsius in July, that is, a range of only 9.3 degrees Celsius. Even on large land masses, coastal lowlands have moderate temperatures all year round, as they are moderated by moisture-laden sea breezes. For example, Sydney in Australia. Large continental land masses such as Asia have extremes of climate. For example, one town in Russia has the largest temperature range in the world. That is a temperature range of 61.8 degrees Celsius. Ocean currents also have a big influence on climate. 70% of this planet is ocean. When an air mass passes over a warm ocean current, the air mass is warmed. When an air mass passes over a cold ocean current, it is cooled. Finally, the world is divided into a series of air pressure systems. Some are high pressure and some are low pressure. Air pressure is measured in millibars, with low pressure being associated with high winds, rainfall and warm air. High pressure is associated with clear skies and a greater temperature range, since there are no clouds to block incoming solar radiation during the day and no clouds to stop radiation escaping during the night. There are high pressure areas at the poles and subtropics, and low pressure cells at the tropics and subpolar regions.